Okay, so if we're talking about anti-differentiation, what we're doing is we're taking the antiderivative. So if I'm given some function, if I want to find the antiderivative of something like x squared, first of all, what does that dx mean? I don't think I went over this in the notes. The dx means with respect to x, in the same way that if we're asked to find the derivative with respect to x of x squared, that would be 2x. Because we're taking the derivative with respect to x. So I was asked the derivative with respect to t of x squared. That would be 2x dx dt. And that's where the implicit differentiation comes into play, and that's where it gets confusing. So we're going to ignore that, or we're not going to ignore that. We're going to, we have that same idea with this dx, is that we're integrating with respect to x. If we were integrating with respect to a different variable, it gets, well, that's Calc 3, so we're not even going to worry about that. So if we were to integrate this function, we want to do it exactly backwards. So in the derivative, the method for the power rule, because this is an exponent, so the method for the power rule is to multiply by the power rule and then take one away from the exponent. So we want to do the exact opposite. We want to add one to the exponent and then divide by the new exponent. So in this case, I want to add one to the exponent, it would be x cubed, and then I want to divide by that new exponent, 3. And don't forget your plus c. This is very important because let's say that I want to take the derivative of this, and this is the whole idea with an antiderivative. If I want to take the derivative of this function, if I took the derivative with respect to x of x cubed over 3 plus c, the derivative of x cubed would be 3x squared, but these 3's would cancel out, so I would be left with x squared, and this plus c is a constant. It's some constant, I don't know what it is, but when I take the derivative of a constant, it's 0, so I'm left with just x squared. So the idea with this is if I take the antiderivative, I get a function. If I take the derivative of that antiderivative, I should end up with the original function, which I have. So that means I did this properly. This is one way to check it. But that's where the plus c comes in, is that when I take the derivative, I should get the original function. And I don't know, I mean, that could have been a 2, c could be a 2, a 17, pi, e, phi, square root of 17, I don't know. It's a number, whatever that number may be. But there's that, so let's do another one. How about the integral of, let's say, the square root of x dx. If I'm trying to do this, first of all, square roots, that's a little bit confusing, so maybe I should rewrite it as an exponent. This is x to the 1/2 dx. And I'm going to use the exact same idea of the phrase that I remember for integration of exponents is rise and divide. So with this, I would want to rise the 1/2, increase it by 1, rise, which would be x to the 3/2. And then if I divide then by this new exponent, divide by 3/2, I would divide by 3/2. It's the same as multiplying by 2/3. Plus c. Never forget the plus c. So again, if I were to take the derivative of this, the derivative with respect to x of this 2x to the 3/2 power over 3 plus c, that's a power rule. I would take one, I would multiply by 3/2, but multiplying by 3/2 cancels with this 2/3, and I would take one away from the exponent, and I would be left with x to the 1/2. And the derivative of c is 0. So I'm left with my original function. This is good, it worked out again, great. What if I took the integral of the tangent of x secant of x dx? Now this, I have to ask myself, well, the derivative of what is tangent x secant x, or secant tangent? I think I usually say secant tangent. I don't know. It doesn't matter. It's a product. Products are commutative. Doesn't matter. So the integral of secant tangent would be, would be secant plus c, because the derivative of secant is secant tangent. So the integral of secant tangent is secant. If I wanted to take the integral of the cosine of x dx. Well, I have to ask myself, the derivative of what is cosine? Well, the derivative of sine is cosine. So the integral of cosine is sine plus c. Okay, so this is how integration works. You're just doing the derivative. You're trying to undo a derivative, and this is how you do it.